Hey guys, it finally happened. Gears and Gear got himself more pieces of Soviet smart warfare. Granted, from the early 60s or something like that. This thing right here is the radar seeker head out of a Kvadrat missile. It's out of the model number is the 3M9M, code name Gainful. NATO designations are weird. And this is a semi-active or almost completely passive, actually, surface-to-air missile radar seeker. Yes, this is the radar head out of a rocket, and I have the photos to prove it. Apologies for my lack of talking hands in this segment. It's far too big to fit in frame. It's far too big to fit on my desk. It's a monstrous piece of equipment, and this is the only conceivable way I could show you this thing. We're gonna go into a lot more detail about it, and if I'm lucky, Mr. Le Labo de Miquel might be interested in taking a closer look at this thing in the future. He's far more experienced of an avionics engineer than I am. I'm not an avionics engineer. And I am going to try and get in touch with him, see if he'd be interested in taking a look personally at this here piece of equipment. So, that being said, how did I get this thing? Well, it all happened at the flea market, of course. I went to the flea market, I think one of the last weeks of 2024, found one of my regular suppliers had one of these available for sale. Just the top bit, I think up to here, including some of the RF stuff. We're gonna get into more detail soon. So he had the dish, the motors, the rotary stages, the gimbal, basically. This is a 2-axis gimbal, and a bit of the RF. And asked how much. And he said a price. I haggled. He said the same price. I ended up paying the same price, basically. And I took it home. It was an interesting drive, having what looked like a tiny radar dish on my passenger seat. But I took it home and started digging into it because I really didn't realize the momentous occasion that I'd been presented with. So I found a number of interesting things in the radar front end, basically. And I am gonna talk about them a bit in more detail, but I have no idea about RF. And yeah, there's a whole load of nonsense going on around here. What I can tell you is that a few days later, a few internet research hours later, I found I found an image, I'll try and insert it here, of what the actual missile looks like with a cutaway section, so exposing this thing. So obviously, Alex couldn't help himself, so he texts the guy I got this from, and I ask him, do you happen to have the bit underneath? And he says, yeah, sure, how many do you want? And I'm like, wait, you got multiple? And yeah, he sends me some photos. He's got like a dozen of them. And he had one that was still in the shell, so the green army shell. Sorry for the bump on the tripod. And still had a bit of the aluminum ceramic nose cone. I think all of the nose cones were smashed way before he got them. So I asked him how much, and he names a price which was exorbitant, but I just couldn't help myself. So I drove by to his lair, and I took the thing, put it in the trunk of my car, and very nervously drove about, I don't know, 5 or 6 kilometers till I got home. Taking it out of the car into the elevator, into the apartment was a bit less nerve-wracking because the thing had already made it relatively in one piece in heavy traffic. By the way, this is my safe space, my corner. This is where I more recently shoot stuff. You can see this here is the mount for the camera, well, for the phone that I use to film stuff. Power supplies, electronic loads, signal generator, the 224, a DMM, some Keithleys, big scope, soldering, more power supply. And behind here, there's more power supplies. There's some inspirational graphics there and some stuff that you can't really see at the moment. And that's where I usually keep my laptop. Oh, and there's a source meter and a nanovolt meter over there. And some more stuff on top, but you'll get to see that in a while. So without further ado, and getting past this short presentation of my home lab. Oh, by the way, hand tools and cables. You gotta have these. I'm gonna try and get you in a bit of a better angle and show you some more stuff from the inside of the rocket. We can go from top to bottom if you want. Actually, if I want, it's my video, so I decide. But what I can tell you is that this thing is crazy. So the bottommost part, what I can imagine and can understand is that it's mostly power supplies, without the exception of this corner here. I'm not entirely sure what's the purpose of this corner here, but there's some RF stuff, and behind this area here, there's a very weird accelerometer that's mounted basically on the center axis of the missile itself, or what I assume was the central axis of the missile. Down here in this corner, there's some detector diodes, I think. They seem to be fed on some sort of waveguide. And in here, this thing right here, I have a video about it, like a video of a clip I'll insert. This thing is something that was easily accessible from the outside of the missile. So you took off a panel with 4 or 5 screws, and that panel revealed the thing that can be extracted and replaced with something else. I'm assuming that's a key, like radar frequency key or something like that, or an activation key, or I have no idea. These things were crazy, so I'll get into more detail a bit later if I remember. But yeah, this thing was meant to have like almost a 20-mile range, fly at Mach 1.6, have a kill probability of 0.7. I have no idea what that means, but I'm assuming that out of 10 rockets, 10 rockets fired upon targets, 7 would hit. And yeah, it's just, this thing was built in, I think, the 60s or 70s or something like that. There's a mess of components in here, including vacuum tubes, early integrated circuits, transistors, all sorts of stuff. And yeah. So let me get you on a more pleasant angle, or let me get you closer up to the thing, and we can discuss more about starting with the rocket head itself, the radar dish. Okay, I'll be right back. Right, so starting at the top here, we have the antennas, the main receiver. So the antenna is a paraboloid, and it receives the radar bounced off of the target, and it concentrates it into, there's 3 openings. There's one central one down the middle and 2 on either side. This is, from what I understand, for a monopulse type radar, which is very complex, but it basically involves 2 slightly shifted radar pulses being sent from the same transmitter, and knowing the angle difference between them, you can get closer and easier to the target, basically. And this feeds into basically this is a waveguide, and it feeds into a coaxial to waveguide termination here. It's not a termination, it's a conversion. So you can see there's 3 coaxes coming from the feed horn, or whatever you want to call it, whatever it's called. And they go deeper into the rocket, into the next level, basically. This thing moves on 2 axes, one here and one here. And because I've dug through the other rocket, the other Seeker radar dish, I've actually done a bit of investigation regarding these parts right here. So this is the main motor that spins the thing around. This motor is actually responsible for this motion right here. This is a twin precision potentiometer, and there's a window here. You can see this in my back video. There's a window here with degrees, so it's marked as degrees of rotation in relation to the shaft, and by the looks of it, it kind of spins how many degrees this turns around its pivot point. This here is a, it looks like a brushed DC motor inside. It smells like one. It tastes like one even, believe me, I've tried. But I think it might be some sort of tacho generator or something like that. I'm not entirely sure. I suspected it was some sort of fine trim for this while it's flying, but I don't think this thing has enough oomph to move this. This is quite a massive device, and under acceleration there's no chance it's going to move it, but once it's flying, I'm not sure it could really affect this in any meaningful way. This is quite a beefy little motor, and there's quite a lot of speed reduction in here, so there's a lot of gears inside. This thing isn't, I couldn't even get this thing completely off. I had to strip off the parts first, and then I could just infer about the complexity of the design, the mechanics inside. The pivot for this thing isn't really special, so this axis just pivots on a couple of bearings, which is relatively simple because it doesn't have to carry any extra complexity, just 3 cables. But I'm going to soon move a bit lower, and I'm going to show you the other axis and the lengths they went to get this thing to move side to side like this. So the second axis, or what I call the B axis, so this is, I think you saw the paper here saying A, this is the B axis, and it rides on bearings. So these are, I think, 28 bearings in total, if I remember correctly. There's 7, there's 14 here and another 14 on the other side. You can just barely make out the last one here. I think these were pressed in, put in, installed, mounted by a very, very patient man. I don't think it was Ivan or Sasha. It must have been some very, very patient Vladimir or something like that, because each of these shafts is eccentric. So when they tighten the thing in, there's a lock washer over each nut, and they twist the eccentric shaft in order to get the basically to eliminate all the free play in this semicircle here. So all these need to be hand tweaked, and the lock washers need to be hand staked afterwards. And as you'll see, every solder joint on this thing has lacquer on it. This pink stuff, it's lacquer. It's meant to protect the solder joint, and it makes it a heck of a long cussing show for anybody who's trying to take apart something like this. In here, you can barely start to make out the beginning of the radio frequency section. I'm gonna call somebody to hold in my hernia while I move this thing around so you can see a bit better down in there, because it's really fascinating. There's a lot of cool stuff in here. I have no idea what most of it does. Right, so I don't think you can barely make out. So this is the motor for the other axis. Associated motion control stuff. So I forgot to mention, this entire assembly here basically forms a servo, a DC brushed servo motor. And in here, there is a very weird device. I'll try and insert some images of it, but basically what happens is two of the signals that come from the rocket are fed through waveguide conversion, and they're fed into a spinning septum that is spun by a synchronous an asynchronous rather, AC motor somewhere deep in here. And that asynchronous motor basically moves the septum and I think mixes or moves stuff between paths or something like that. There's a very weird combination of waveguide components and coax and stuff like that between these parts here. It's really crazy. By the way, these donut things here that were also on this board, I think these are just chokes for the motors. They seem to be in line with the motors, so they're chokes probably to filter noise or something like that. I'm gonna try and spin you guys around a bit more and show you some other stuff, because I've kind of already made a small effort of identifying some of the stuff, and I did have some progress. I'll be right back. Okay, so these two bits, because there are two of them, trust me, one's behind the other. These are gyros, and I have taken them apart. I have actually taken one apart, and I've actually powered them on. They run off of 26 or 28 volts AC, 3-phase, 400 hertz. They spin very, very fast, and they're quite scary when they spin. Also, they're in good gyro fashion. There's a copper harmonica style thing. It's a copper bladder that's meant to absorb the expansion of and contraction of the hydraulic oil that's in here, to account for variations in altitude, basically, so as not to compress or to press in on the precise mechanics that's going on inside. And these are the things that convert the waveguide from the antenna, which is up there, into coax cable. The entire antenna, as you've seen, is covered by some sort of fiberglass mesh or something like that. I'm gonna move you just a tad lower, and I'm gonna talk to you about the first bit that I identified in this whole rocket. Alright, so this is the best angle that I could find. This board, these two assemblies are rather, this one here and this one here, are identical from what I could tell. And it makes sense because these are the servo amplifiers for the DC motors that move the radar dish. What makes me say that? Well, they go straight through to the electric motors. I've actually buzzed the connections out, and I found some pins going to the motors. I didn't have any more patience to buzz the pins out for the potentiometers or anything else, but there's also some giveaways. One of them is that there's two big transistors here. One of them is here, one of them is here. You can't really see that first one. And these are probably driving the motor either side. I think there might be more transistors that are hidden from sight, or this is just a push-pull stage that's being applied to the motor, which is powered from symmetrical power supplies. Might be something like that, like a power op-amp driving the motor. I don't know. There's a lot of components in here. These are old transistors. These are some very early Soviet integrated circuits, very high precision capacitors. These are basically, as a friend of mine put it, hi Stan, these are basically palladium foil on ceramic, and they're very expensive and very sought after by metal recyclers. And I think you can barely make it out here that each and every wire is individually hand numbered. All the solder joints are done by hand, of course. This is Teflon insulated, Teflon coated wire, so there's sort of like a Teflon fabric or silk or something like that, and then there's another layer of Teflon on top. This is very, very nice wire. It's silver plated copper as well. And everything is hand bound with this wax string here that you can see. It's just insane. I can't even imagine how much this thing would have cost. I think it would have cost something like a village's, city's entire budget for a year or something like that. It's just inordinate amounts of money were poured into this thing. And this is the only uh, sidetrack that I'm gonna go on this thing. It always fascinates me just how much money are invested when it comes to creating things that end other people, you know? So innovation in military has never ceased, and it never ceases to amaze me just how far people are willing to go. Okay, politics aside, this thing is really cool. So as I said, these two servo drivers for the stages, and let me move you just a tad and show you some more stuff down below. Okay, so this nightmare around here is basically a mystery to me. I have no idea what's going on. I just know that there's about a dozen trimmers on this board, and these all of these three things are just beefy, shielded, soldered together cases, so they must be doing something sensitive. I'm assuming, because I traced some wires from the two gyros, I'm assuming that these are the bits that take in the signal from the gyroscopes and control the servos in accordance, or send signals further down to the rest of the rocket, to the control surfaces or something like that, maybe. I have absolutely no idea what's going on around here. What I can tell you though is, just again, look at the amount of work that's gone into this thing. Remember, this is going into a rocket that goes almost twice as fast as the speed of sound. It has to maneuver, it has to have extreme resilience to acceleration, it has to be extremely robust in every shape, way, form, or conceivable. So you can imagine just how much effort was put into building this thing. And I don't even know how they started the design or the manufacture of this thing, because it feels like it was assembled never to be disassembled again, or it feels like it just birthed itself into existence like this. I cannot imagine how this thing was assembled. Every bit you try and take off is underneath 10 other bits that are underneath 10 other bits, and it's on a sort of Ouroboros situation where it really doesn't lend itself to be taken apart and investigated easily. I think that was a major part of the design criteria for this thing, because if one of these were lost, reverse engineering this would have been catastrophic for the Soviet government. So because they went into so much they went to so much trouble to build this. Yeah, it reminds me of the story of the Russian deserter who flew the MiG-23 to Japan, and the MiG was disassembled piece by piece and given back to the Russian government or something like that in pieces, and they couldn't do anything about it. Fun. Okay, and this is another bit that I have no idea about, with a few tiny exceptions. There's a couple of vacuum tubes on this board. There's a couple of sets of those precision potentiometers on this assembly here. This, I'm pretty sure, is a synchro solver or a Selson or something like that. And I have no idea where these assemblies all come from and go to. My suspicion is that this has something to do with the control surfaces of the missile. I don't know, it might even be some sort of integrator, mechanical calculator or something like that. I've got no idea. But one of these boards around here, I think this one here, has the most trimmers I've ever seen in one board. I have no idea why, I have no idea how, but there's a monstrous number of trimmers, just crazy. A bit lower, if I'll be able to move you without upsetting you too much. So these are the three main wired connections that mate this bit of the missile to the rest of it. Underneath this plate here, which I cannot remove, is a three-phase transformer. So this thing, as I said, ran off of a pressurized air, compressed air turbine that was fed from a compressed air tank, and the turbine generated 400 hertz three-phase power, I think at 230 volts or something like that. The asynchronous motor that lives in the RF front end was rated for 230. So the transformer, I think it's barely visible. You can sort of see a corner of it around here. And these connections should carry power and control signals between this bit and the rest of the missile itself. The rest of the bottom section of the missile itself is basically power supplies, and that's about it. There's big electrolytic capacitors in here, those sealed donut-shaped ones. I think you've seen them on eBay, and that's about it. One last thing before I move you to the weirdest part of the missile, the one that I understand the least. In behind here, way deep inside, I've actually taken this panel off. I might even try and do that now. I'm gonna shoot myself in the foot doing that, but behind here is basically a like this long accelerometer that is facing straight up in the middle of the center of mass of the thing. So I'm assuming that it has something to do with throttling the engine. This might also be an explanation for this thing controlling the speed of the rocket, considering it's close to the accelerometer. But from my understanding, this was a solid fueled rocket, and I don't think those really could be throttled. But yeah, who knows? Okay, let me see and decide what I'll do next, if I take this panel off or if I show you the last section. Oh, by the way, the section that I previously showed you is perfectly identical to the one that's right behind the rocket right now. So there's a couple of assemblies that are complete duplicates of one another. Makes sense, there's two axes of freedom for the radar dish. Okay, so I did manage to sort of extract this thing from out of here. This cylinder here with the ribbed pipe basically sticking out of it is the accelerometer. I've actually found the model number for it. It's very, very weird. This is a twin triode. Fascinating to see. These are all trimmers, so this component here is a trimmer, and it's very interesting because it's a basically a worm gear, and the worm gear rotates the cursor, or rather the actual carbon trace over the cursors. So very neat way of doing that. These are also trimmers, but they're more conventional. These were, I think, required where space was at a premium. And I'm gonna try and move you so you can see this side as well, but there's just a boatload of relays and other components around here. It's super interesting though. So, as I said, not much on here. These are all electrolytic caps. These are 15 microfarad, I think 20 volts or something like that. This is a paper and oil cap. These are all transistors, and you can see just how many of them there are and how varied the mounting positions they chose. And you can sort of, if I twist it around a bit, maybe you can see a bit better the accelerometer. I'm gonna try and insert a photo of it. I actually managed to take it out pretty much entirely out of here and reverse Google image search and did all sorts of stuff to find more info about it. Also, one thing to note, this thing did not really want to come apart. So every screw was, there's nothing tighter than stripped. Every screw is covered in some sort of lacquer or varnish. So you can even see them here. So these screws are all covered in some sort of, I think it's the Soviet equivalent to Loctite, but way more pervasive. And I think these things were screwed together by very, very strong people. So it's a nightmare to take them apart. Okay, so this entire bit here, I think, in all, considering everything I've learned about this thing from now, up till now, this is a coax coming straight from the radar bit. This thing plugs and unplugs in a very interesting manner. And I think I mentioned this was accessible from the outside of the rocket. No idea what it is. It's got some places where you can trim 2 caps and 2 test points and a resistor. I think this was a key or something. It's got a big number 3 written on it. Behind it, there's, I think, some sort of microwave filter, and it basically steals off the signal from the RF section above and moves it through the filter or whatever the component in there might be, and then spits it out the bottom. There's a waveguide connector about here. Now, in the documentation, in the rumors about this thing off of the internet, the next thing following this thing in the rocket was a radar proximity fuse. So I'm assuming that waveguide connector, that is this coax here fed into the waveguide around there, might have something to do with the trigger. So the explosion, the boom. Yeah, that's about everything I know about the rocket and the radar seeker. There's a few more interesting tidbits around here. As I said, most of this section here is power supply, with the exception of this bit of RF here. This is a waveguide. And in case you're wondering what's in here, because there's a lot of D's, this is the Cyrillic D. This is D1 and D2. These are diodes in here. Let me go fetch one for you guys. So these are the diodes. I think it's the right way up. It's a D405 VBP or something like that. I've heard that these are microwave mixers or detectors. I'm pretty sure these are Schottky diodes, and there's one of them in each of these housings here. They're smack dab in the middle of the waveguide cavity. So this thing, by the way, was supposed to operate at about 10 gigahertz as the frequency of interest. And yeah, this is the waveguide connector that you can see transitioning through this bulkhead, basically down to the lower guts of the rocket. And I remember I told you about that transformer, where the transformer is right there behind this wall here. And this is a bridge rectifier by all looks. So at some point, I am going to try and apply like 28 volts, 20 something volts in here and see what happens. Maybe I get some filament glow or something like that for some tubes. This is a decimal hour runtime counter, and I'll bring you in closer so you can see it. And yeah, that's about it. This assembly here is just completely defeats me entirely. Lots of these big power resistors that can be trimmed as well. There's one over here as well. I think you can just barely make it out. enormous amounts of work went into this thing, absolutely enormous amounts. And yeah, again, fascinating how much effort people can put into making a very bad day happen for other people. By the way, fun fact to lighten the grim mood. These are very static sensitive. Don't worry, I'm touching the ESD safe mat. Actually touching the bright shiny point you're supposed to wire yourself into. These were delivered in small lead envelopes. That was the Soviet Union's idea of ESD protection. So when these came from the factory, they were sealed in lead pouches, tiny lead pouches, one pouch per diode. Okay, I'm gonna bring you in and show you the runtime counter, and then I have some more video for you if I haven't already inserted it amongst the quiet sections of me hand waving and doing stuff, showing stuff. Okay, so I think you can make out the runtime counter in here. Funny enough, it actually says hours in here, so I think this is the only English writing I've seen in the entire device. Really crazy. As I said, this is the the waveguide termination, and there's a lot of magnetics in here, power transistors mounted on heat sinks. There's loads of structural elements for the power supply section as well. So I tried taking this thing out. It was a bear to undo these two screws, but it left me with absolutely nothing, because the entire thing is anchored in probably a dozen other places. So I've kept this thing as intact as possible. Basically, I've barely even scratched the surface, so not even starting to talk about actually unsoldering some of these cans or something like that. No way. I tried to, take a look under the under its skirt. Sorry for the stupid idiom, but that's the best I could do. But it's really hard to identify any components of this thing for somebody who's used to more Western electronics and stuff like that. So this thing is a completely different language to me, especially considering the fact that there's so much RF stuff that I can't even wrap my head around. It's converting from waveguide to coax, back to waveguide, back to coax so many times that it's not even funny. So yeah, this is almost 40 minutes of me ranting, talking about a piece of basically smart munitions. A very interesting topic. I hope I did it justice, and I hope I haven't bored your ears off. I'm gonna leave you with one word of advice, if I may. Try and do as little harm in your life as possible. Not everybody can do good all the time, but try and do as little harm as possible. We should minimize the negative impact that we have on those around us, and this thing is an example of the wrong way of doing it. Okay, catch you next time. Bye. Oh, sorry, one last thing. Hold on, I have to reposition for this. I've noticed just today actually that a very nice gentleman off of YouTube by the name of Le Labo de Michel has subscribed to my channel. First of all, I want to thank him. He's a very talented avionics engineer, electronics engineer, and he has very interesting content. He also speaks French, which is kind of a first, because he's the only French speaker on YouTube that I subscribe to whom I subscribe to. Now, he actually had a tiny fragment of one of these missiles, and to which I cordially extend my invitation for a collaboration. Monsieur Michel, si vous voulez, je peux vous envoyer cet radar ici et vous pouvez faire ce que vous croyez que c'est intéressant avec il. Apologies for my terrible French, but the point is I'm just offering this package here to Mr. Michel. Maybe he can put it to work, or maybe he can explain it better than I did. I'm certain that he can. And that would be a very, very interesting thing to see, I think. I'm even willing to cover some of the shipping costs if that's necessary. Only in Europe, by the way. Anyway, I've rambled on long enough. I hope you all have a great day, and I hope you like this video. And once again, thank you very much for watching. Bye!